We like to think of our solar system as a solved puzzle, a clockwork machine where every gear and every world has been mapped. But in the cold, blue silence of the outer reaches, there is a giant that refuses to follow the rules of the family. Uranus is a world that seems to have been knocked over by the universe itself, spinning on its side in a lonely, eternal stumble. While the other planets stand upright like spinning tops, this ice giant rolls through the dark like a ball discarded by a cosmic child. It is a place where summer and winter last for 42 years, and where the sun barely registers as more than a distant, chilling spark. For centuries, we didn't even know it existed, as it moved so slowly across the stars that it was mistaken for a fixed point. When William Herschel first spotted it through his homemade telescope in 1781, he didn't think he had found a new world at all. He initially reported it as a comet because the idea of a seventh planet was simply too big for the science of his time. This discovery shattered the boundaries of the known universe, proving that the solar system was twice as large as humanity had ever imagined. But as we looked closer, the triumph of discovery turned into a deep, scientific bewilderment that continues to haunt astronomers to this very day. Why would a planet of such immense scale be tilted at a nearly 98-degree angle, defying the very physics of planetary formation? To understand this mystery, we have to look back nearly 4 billion years to a time when the solar system was a violent nursery. In the early chaos, the path of a planet was not a peaceful orbit, but a frantic survival dance amidst trillions of tons of debris. Modern science suggests that Uranus didn't just stumble. It was likely the victim of a series of cataclysmic, world-shattering events. A giant impactor, perhaps twice the size of Earth, might have slammed into the young planet with enough force to flip its entire axis. Or perhaps it wasn't a single blow, but a long, slow gravitational tug-of-war with a moon that has long since vanished into the dark. This tilted existence creates an environment so extreme that it challenges our basic understanding of how a planetary atmosphere should behave. On Uranus, the North Pole points almost directly at the Sun for decades, while the other half of the world freezes in total shadow. Yet, strangely, the equator remains warmer than the poles, a paradox that suggests the internal heat of the planet is hiding a secret. As we peel back the layers of this turquoise enigma, we realize that Uranus is not just a planet, but a witness to our history. To look at Uranus is to stare into a pale, featureless mirror, but the calmness of its surface is a beautiful lie. Beneath the serene cyan clouds of methane lies a world that is not a gas giant, but an ice giant. Unlike Jupiter and Saturn, which are mostly hydrogen and helium, Uranus is packed with heavy, exotic forms of water and ammonia. Under the crushing weight of its atmosphere, these substances exist in a strange, hot, fluid state known as a supercritical sea. This deep interior creates a magnetic field that is as chaotic as the planet's tilt, wobbling wildly as the world spins. If you were to descend into this world, the pressure would become so intense that it could rewrite the laws of chemistry. Scientific models suggest that at these depths, methane molecules are squeezed until they shatter, releasing their carbon atoms. These atoms then crystallize under the heat and pressure, forming trillions of tiny, sparkling diamonds that drift through the dark. It is a place where it literally rains diamonds, a glittering shower falling forever toward a solid core of rock and ice. This hidden opulence is surrounded by a ring system that is almost invisible, dark as charcoal and thin as a hair. These rings were discovered almost by accident in 1977 when astronomers watched the planet pass in front of a distant star. The star's light flickered off and on before the planet even arrived, revealing a series of narrow, jet-black hoops in the void. These rings are not the bright, icy displays of Saturn, but are likely made of organic material darkened by millions of years of radiation. Dancing among these rings and beyond are 27 moons, a collection of worlds named not for gods, but for literature. While other planets honor the Roman pantheon, Uranus pays tribute to the fairies and spirits of Shakespeare and Alexander Pope. There is Titania, the queen of the fairies, and Oberon, the king, both massive spheres of scarred ice and ancient rock. But the strangest of them all is Miranda, a tiny moon that looks like it was smashed to pieces and glued back together. Miranda features the Verona Rupes, a cliff so high that a human jumping off the top would fall for over 10 minutes. The existence of such extreme geology on such a small world suggests a history of violent tidal forces and internal melting. These moons and rings are the silent witnesses to the cataclysm that knocked Uranus over, carrying the scars of a forgotten age. Despite being a giant in our own backyard, Uranus remains the least explored of all the major planets in our system. Humanity has only ever visited this blue world once, during a fleeting encounter that lasted just a few hours. In 1986, the Voyager 2 probe streaked past, capturing the images that still define our understanding of the planet today. It revealed a world that looked surprisingly calm, like a smooth billiard ball floating in the dark, icy ocean of space. But that brief glimpse was like looking at a photograph of a storm and assuming the air was perfectly still. Since then, we have relied on the Hubble Space Telescope and massive ground-based observatories to watch from billions of miles away. These distant eyes have seen things Voyager missed, like massive, seasonal storms that suddenly erupt across the cyan clouds. Because of its extreme tilt, Uranus experiences the most dramatic change in sunlight of any planet as it orbits the Sun. When the sunlight finally hits a region that has been dark for 40 years, the atmosphere reacts with violent, surging energy. Giant clouds of methane ice crystals swirl at high altitudes, whipped by winds that can reach over 900 kilometers per hour. This hidden activity suggests that Uranus is not a dead, frozen ball, but a world with a complex, rhythmic heartbeat. Yet, the most unsettling mystery discovered by Voyager 2 was not the winds, but the planet's strangely lopsided magnetic field. On Earth, our magnetic poles roughly align with our rotation, but on Uranus, the magnetic field is tilted 60 degrees away. It doesn't even pass through the center of the planet, making it a staggering, off-center mess that defies simple explanation. Scientists believe this messy field might be generated by a thin, churning shell of salty, conductive water deep within the ice. This magnetic corkscrew interacts with the solar wind in a way that creates a chaotic, tumbling shield around the planet. Every time we try to model this world, we find that Uranus is weirder than the math says it should be. This lack of data has created a Uranus gap in our knowledge of how medium-sized planets actually work and evolve. We are left wondering if Uranus is a freak occurrence or if it is actually the most common type of planet. To find the answer, we must go back, but the journey is a challenge that tests the limits of our technology. Reaching Uranus is not a simple journey. It is a marathon through a cold, empty desert spanning billions of kilometers. Any probe we send must travel twice as far as it took to reach Saturn, a feat of endurance for both machine and mind. Because the Sun is so distant and weak at these reaches, traditional solar panels are useless, leaving our machines in the dark. Future missions will need to carry small nuclear batteries, glowing with the decay of plutonium to keep their electronic hearts beating. The sheer distance also means that a radio signal traveling at the speed of light takes nearly 3 hours to return home. If a crisis occurs on the spacecraft, it must solve its own problems long before a human engineer on Earth even knows something is wrong. Despite these hurdles, the scientific community has recently declared a mission to Uranus as their highest priority for the next decade. NASA and international partners are now sketching the blueprints for the Uranus orbiter and probe, a mission unlike any before. This spacecraft wouldn't just fly by, it would settle into a long-term orbit, becoming a permanent resident of the ice giant system. It would carry a small, shielded atmospheric probe designed to do something no human eye has ever done: dive into the clouds. This sacrificial messenger would plummet into the cyan depths, measuring the chemistry and pressure until it is crushed by the world. The data it beams back in its final moments could tell us exactly what materials were present when the solar system was born. We might find that Uranus formed much closer to the Sun before being kicked out by the gravity of Jupiter and Saturn. This theory of planetary migration suggests that our solar system was once a chaotic game of musical chairs with giant worlds. By studying the chemical fingerprints in the Uranian air, we can finally map the movements of these ancient, wandering giants. The mission would also turn its cameras toward the moons, searching for signs of hidden oceans beneath their fractured, icy shells. If we find liquid water inside Titania or Ariel, it would mean that life's ingredients are scattered much further than we thought. Every moon is a potential laboratory, a frozen time capsule waiting to be opened by our robotic explorers in the 2040s. But this mission is more than just a search for facts. It is an attempt to close the gap in our cosmic identity. We cannot truly say we understand our home until we understand the strangest member of our planetary family. But Uranus is not just a scientific curiosity. It may be the key to understanding the billions of worlds beyond our own. When we look at distant stars, we find that ice giants like Uranus and Neptune are the most common type of planet. By decoding the secrets of our own tilted neighbor, we are essentially learning the rules for the majority of the galaxy. We are finding that the universe is not filled with perfect Earths, but with strange, sideways worlds of ice and shadow. If we ever hope to find life among the stars, we must first understand how these cold, chemical-rich giants function. Perhaps life doesn't always need a bright yellow sun and a rocky surface to spark into existence. Could the moons of an ice giant, warmed by tidal friction and chemical energy, provide a haven for life in the deep dark? To answer this, we must look at the habitable zone not just as a distance from a star, but as a condition of energy. Uranus challenges our Terran bias, forcing us to rethink what a normal planet looks like and where life can hide. It reminds us that our solar system is not a static museum, but a dynamic, ever-changing neighborhood with a violent past. The fact that Uranus is broken and tilted is exactly what makes it such a precious witness to our cosmic origin. Its orbit is a 4-year-long journey that spans more than a human lifetime, a slow-motion dance through the outer dark. Since its discovery, Uranus has only completed 2 full trips around the Sun, a reminder of how brief our observation has been. We are like mayflies trying to understand the seasons of an ancient oak tree, observing only a tiny fraction of its life. Yet, in that short time, our curiosity has transformed a tiny blue dot into a complex world of rings, moons, and mysteries. This drive to explore the useless and the far away is what defines us as a species, pushing us toward the horizon. We don't go to Uranus because it's easy, but because its strangeness is a mirror that reflects our own thirst for knowledge. Every sensor we send and every photograph we take is a bridge across the cold void, connecting us to the infinite. As we prepare to return to the ice giant, we are stepping out of our comfort zone and into the true scale of the universe. The blue giant is waiting, rolling through the dark, holding the secrets of where we came from and where we are going. But perhaps the most profound question Uranus leaves us with is not about its tilt, but about our own place in the cosmos. We look at this sideways world and see a misfit, but in the vastness of the galaxy, we are the ones who might be the exception. Most planetary systems we discover do not look like ours. They are crowded with ice giants and chaotic orbits. Uranus stands as a bridge between the familiar rocky ground of Earth and the truly alien environments of deep space. It is a reminder that the universe does not owe us an explanation, nor does it have to conform to our ideas of order. If a planet can rain diamonds in the dark and spin like a fallen top, what else is waiting for us in the silence? Our journey to this distant giant is a testament to the fact that humans are the only part of the universe that asks why. We are the eyes of the solar system, looking back at the chaos that created us and trying to find the pattern. As our probes begin the long trek toward the ice giant in the coming years, they carry our collective wonder with them. They will find a world of turquoise clouds and jet-black rings, a silent guardian of the outer solar system's history. They will listen to the radio static of its lopsided magnetic field and measure the scars on its literary moons. And in doing so, we will realize that Uranus is not a lonely outcast, but a vibrant chapter in our shared cosmic story. The darkness of the outer reaches is not empty. It is filled with the potential for discovery and the thrill of the unknown. We are finally ready to face the giant, to embrace its tilt, and to learn the lessons it has held for billions of years. The light of our curiosity is enough to illuminate even the coldest, most distant corners of our planetary family. So we keep looking up, keep building, and keep dreaming of the day we finally settle into orbit around the blue enigma. Because every mystery we solve brings us one step closer to understanding the grand design of everything that exists. Uranus is not the end of the solar system, but the beginning of our true journey into the interstellar dark. It rolls on, indifferent to our gaze, yet inviting us to follow its path into the deep, beautiful mystery of space. In the end, we are all just travelers on a tilted world, trying to find our way home among the stars.